Welcome to section 2.2, part 1. Just to make sure you're in the right place, this video is intended to be watched after the first two videos for section 2.1, so 2.1.1 and 2.1.2, as well as after the grade 10 trig review video. So ideally you want to have watched all three of those videos before you start watching this one, or else you're probably going to be a little bit lost. So this video is all about trig ratios on the coordinate plane. And so we've already been doing some standard position stuff on the coordinate plane, but we weren't actually working with coordinates. This video is actually going to work with some coordinate-based stuff. So to get us started, let's imagine that we have some point on the coordinate plane. So we're going to just call it point A. And we don't know what x and y are necessarily right now, so we're just going to say it's got x and y coordinates that are x and y. And that point is on the terminal arm of an angle in standard position. So that comes with all of the things that we know about standard position as far as initial arm, terminal arm, and the vertex. So let's sketch this out real quick. I'm going to draw it in quadrant 1 just because that's kind of the easiest place to draw things. But right, we know nothing about this angle. It really could be anywhere. So there's our initial arm. And if our point A is, let's just say up here, remember our x coordinates are just x and y. And so our terminal arm goes, it can go to that point, it could go through that point, it doesn't really matter. I'll just have it end there. So the kind of main thought process underpinning that is what we're going to do is we're going to make a triangle that connects that point to the x-axis. So something like this. You see, so we've got this dotted line here. So the dimensions of our triangle, right, the length and the width, those are kind of important. So if we're doing trig, right, thinking like SOHCAHTOA, sine, cosine, and tangent, the dimensions of our triangle are pretty important parts of working with sine, cosine, and tangent. And we aren't necessarily given them explicitly, but we do actually have all the information we need from what the question's telling us. So the dimensions of this triangle are just the coordinates of our point. Because if you think about it, so this point, it's generic, but let's pretend it wasn't generic. I'm just going to erase this real quick, but it'll come back. So the way I actually graphed this is the point 3, 4, right? So if this is the point 3, 4, from here, we've gone over 1, 2, 3, which means the length of this line is 3. And we've gone up 1, 2, 3, 4, which means the length of this line is 4. And so that's going to be true no matter what your x and y coordinates are. And so if we're thinking a little more generically again, and this was still just x and y, then those coordinates are just the length and width of my triangle. So this is going to be x, and this is going to be y. Try not to mix up which one's x and which one's y, by the way. The hypotenuse is going to be called r. And that's because there is something called a unit circle, or just in general circles with trig, that you might run into at some point. Not just yet, but just know that it's kind of considered like the radius of a circle. And so to calculate that length, we're just going to use some Pythagorean theorem. So if we just sketch out that triangle down here real quick without having it on the coordinate plane, we've got x, y, and r. And so if we're thinking Pythagorean theorem here, instead of a squared plus b squared equals c squared, it's x squared plus y squared equals r squared. Or if you isolated that and solved for r, it would be r equals the square root of x squared plus y squared. And so if we use that, well then what are sine, cosine, and tangent for this triangle? So sine, right? And we're working with this angle down here, because remember, this was an angle in standard position. So we're taking this angle, which is still down here. This is theta. So sine theta is our opposite, which is y, over our hypotenuse, which is r. Cosine theta is adjacent over hypotenuse, so that's x over r. And tangent is opposite over adjacent, so that's y over x. And so these are going to hold true for any point. But here's the thing. For me personally, I wouldn't recommend memorizing these. It's a lot to memorize and it's easy to mix up the letters. What you do probably want to memorize is this triangle here. So if you can just know how to build that triangle and you know your SOHCAHTOA, which you should, because that's definitely an easy thing to memorize, then you should be fine to figure out your ratios for any point that you're working with. But let's try putting this to work. So I want to determine sine theta, cosine theta, and tangent theta for a point whose terminal arm passes through, let's say, the point 5, 10. Oops, 5, 10, not 5, 0. And we're going to do that, and this is a phrase that you should remember, as exact values. So we'll talk about what I mean when I write that when the time comes. So if we sketch this out just really roughly, we don't need to plot the point properly. We just need to kind of get it roughly where it needs to go. So the point 5, 10, it's going to be somewhere in the first quadrant. I'm just going to put it kind of up there. We're going to draw our initial and terminal arms because this is an angle in standard position. So our angle is going to look something kind of like this. Then we're going to make that triangle that we talked about. So we're going to come down like so. Remember, always going to the x-axis. This is kind of like reference angles, so it's always the closest part of the x-axis, never the y-axis. So our point is at 5, 10, which means our x-coordinate is 5, our y-coordinate is 10, and so those are your length and your width of your triangle. So if we just sketch out that triangle kind of on its own now, we've got 5 and 10. And so if we want to get our hypotenuse here, which is r, we're going to do that x squared plus y squared equals r squared stuff. And so that's going to be 5 squared and 10 squared. So 5 squared is 25, 10 squared is 100. If we put those together, we get 125. And so to get rid of that square, right, we need to square root. And this is where that exact value stuff comes into play. So this is just going to be root 125. We could simplify this a bit. Again, we could do a mixed radical here, and this would become 5 root 5. But we don't actually care about mixed radicals in this chapter, so we're not going to bother. There will be times where this will just work out to a nice number. We'll see an example like that after this. But for now, we're just going to leave it as root 25. And so what we've got is that x is 5, y is 10, and r is root 125. So we're just going to fill that in on our triangle up here. So remember, this is the angle we're looking at. Theta is down there in the corner. So to do sine, cosine, and tangent, we're just going to work with that triangle. So I'm not going to think too much about the y over r, x over r, whatever stuff. I'm going to write them down just as a refresher. So remember, sine is y over r, right? So it's your opposite and your hypotenuse here. Opposite, hypotenuse. So in this case, that's going to be 10 over root 125. Cosine is going to be x over r, which is going to be 5 over root 125. And tangent is y over x, which is going to be 10 over 5. And that one we can simplify. So 10 over 5 is just going to simplify to 2. And so all three of these ratios just come from me looking at this triangle and saying, okay, opposite over adjacent over hypotenuse, adjacent over hypotenuse, and all that stuff. I don't need to think about these three things. You can memorize them if you really want to. Just know that I don't necessarily recommend it. And again, we could do mixed radicals here. If we did, and I'm not going to generally, but if we did, This one would simplify to 10 over 5 root 5, and we could simplify those to get 2 over root 5. And we could even rationalize that if we wanted to. So remember rationalizing from chapter 5. If we multiplied the top and the bottom by root 5 here, this would become 2 root 5 over 5. And so your textbook will probably do this in some cases. And so when you're getting answers in your answer key at the back of the book, sometimes your answers are going to look a little weird. They might look like this. So the next one, if you did all this, would end up as root 5 over 5. And the one at the end is always good. But again, I'm not expecting you to do this. Don't worry about it too much. Just know that is a thing that can happen, but isn't really the focus of this chapter. And so there we have it. So we're going to basically do this for any point that we're working with here. And so we're going to do this again now, but we're going to do it with 4 points. So I'm going to make myself a little table here just to kind of help keep things organized. So it's not a bad idea for you to do the same. And so once this table is all set up, I'll explain what the question actually is. Okay, so we've got our table. And same as before, I'm going to want you to find the sine, cosine, and tangent ratios. But we're going to do it for 4 specific points. So it'll be the point 3, 4, negative 3, 4, negative 3, negative 4, and 3, negative 4. So you note x and y values are all basically the same, just sometimes positive, sometimes negative. So I'm going to go through one of these just to kind of help set the tone, and then you'll be able to do the other 3 for yourself. So for the first point, 3, 4, this is in quadrant 1. I'm going to throw a little 1 up there. And our r value, remember, r is the square root of x squared plus y squared. So that's going to be the square root of 3 squared plus 4 squared. So that's going to be 9 plus 16, which is the square root of 25. And this is one where we actually can do the square root. The square root of 25 is just 5. So never leave it as a root unless you have to. If you can do the root, always do it. All right, so we've got an r value. And so if I sketch this out really, really quickly, our x was 3, our y was 4, our r was 5. And so if we do our sine, cosine, and tangents, so our sine is y over r, or o over h. So it's going to be 4 over 5. Our cosine, a over h, x over r, is 3 over 5. And our tangent, opposite over adjacent, or y over x, is 4 over 3. So something I want you to keep in mind, just to save you a little bit of time, if you worked with these other 3 points here, negative 3 squared is still going to be 9. Negative 4 squared is going to be 16. So r is going to be the same no matter what, because you're still just going to be getting rid of the negatives. You're still going to get 25. So you're really just focusing on the positives and the negatives here. So go ahead, fill in the rest of this table as best you can, and then we're going to talk about sort of the patterns that you see once we're done. Okay, so filling in the rest, for negative 3, 4, sine is 4 over 5. Cosine is now going to be negative 3 over 5. And tangent is going to be 4 over negative 3. For negative 3, negative 4, sine is negative 4 over 5. Cosine is negative 3 over 5. And tangent is negative 4 over negative 3. And so a negative over negative, those do cancel out, and this just works out to positive 4 over 3. And then for our last point, we've got negative 4 over 5, positive 3 over 5, and negative 4 over 3. So same ratios, just different positives or negatives. And remember, so since these ratios are the same, you should be thinking maybe something about reference angles at this point. It's not relevant for this lesson, but it is something to keep in mind. It is related. I'm going to sketch these out a little more properly just so that we can kind of visualize what's going on here. And then we're going to talk a little bit about what we've got. So if we draw out these 4 angles, so we've got points at positive 3, positive 4, negative 3, positive 4, negative 3, negative 4, and positive 3, negative 4. So if we get our angles in standard position that kind of go through those 4 points, we end up with these 4 angles that look something like this. And so again, you'll see they definitely all have the same reference angle because they have that same sort of straight line look that we saw in the last video. And so these are the 4 angles in standard position that go through our 4 points here. If we make our triangles, you'll see we have basically the same triangle, just in different parts of the axis. So we've got 4s and 3s all over the place. But sometimes those 4s are negative, and sometimes those 3s are negative. So the points are going to be different depending on where you are, but the patterns of positives and negatives are never going to change, right? So when you're in quadrant 1, x is always positive, y is always positive. When you're in quadrant 2, x is always negative, y is always positive. Quadrant 3, everything's negative, and quadrant 4, x is positive and y is negative. So if you look at this table here, and you ignore the numbers, and you just focus on what's positive versus what's negative. So let me get some negative highlights going on here. Right, so those those 6 boxes all led to negative answers. This one down here didn't because the negatives canceled out. So you can see half of our boxes are negative, half of them are positive. And those same ones are always going to be positive or negative for those specific quadrants. So if you look at these quadrants here, this point is in quadrant 2, this point's quadrant 3, this point's quadrant 4. So since the relationships of positive and negatives aren't going to change, if we can remember what goes where, we're always going to know what's going to be positive or negative in a given quadrant. So let's try to boil that down a bit. So which ratios are positive in which quadrants? This is going to lead to a very important and useful memory device. So this is definitely something you're going to want to pay very close attention to. So in quadrant 1, everything was positive, right? Which means our ratios, which relate our different sides, all ended up being positive. So quadrant 1, all 3 ratios are positive. In quadrant 2, x was negative, which meant that both of the ratios that relied on x, so cosine and tangent, both ended up being negative. So the only one that was positive was sine. So in quadrant 2, sine is positive. Quadrant 3, both of our x and y values were negative, which meant that sine and cosine both ended up with negatives because they both rely on x or y. But since tangent uses both of them, the negatives cancel out. And so in quadrant 3, tangent was negative. And then quadrant 4, y is negative, x is positive, and so sine and tangent, both of which used y, ended up being negative, but cosine, which just uses x, and r, ended up being positive. And so those ratios are always going to be positive in those places. So let's boil that down a little bit. So a for all, s for sine, t for tangent, c for cosine. So these ratios are positive and the others are negative. And so our memory tool uses those 4 letters, A, S, T, and C. Different people use slightly different devices here, but the one that I've found most useful, so ASTC, that's just quadrant 1 to quadrant 4, and you'll just have a nice little phrase that'll help you remember things. So we've got all students take calculus. I have also seen people use cast. So if you notice, if you start in quadrant 4 and you go around C-A-S-T, it makes a nice word as opposed to A-S-T-C, which doesn't actually spell anything. But then you're starting in quadrant 4, which doesn't really seem like a great place to start to me. So this is your memory thing, A-S-T-C. So often, on a lot of pages in this unit, you would probably just put this down at the top of the page to help you remember things. So if you're looking at, say, quadrant 3, you know tangent's going to be positive and the other 2 are going to be negative. So let's try putting that to work. I'm going to throw some ratios at you with some angles, and I just want to know whether they are positive or negative. So if we do tangent of 150, sine of 247, cosine of 30, sine of 310, tangent of 200, and cosine of negative 80. Right, so there's a whole bunch of ratios for us. And so we're just going to go through them one at a time. So 150. This is in quadrant 2, right? So if we look in quadrant 2 and we think about our ASTC, well, in quadrant 2, the only thing that's positive is sine. And so since this is a tangent ratio, this is negative. If we go to sine of 247, that's in quadrant 3. And in quadrant 3, the only thing that's positive is tangent. So this one's also negative. If we had switched these two ratios, so if this had been a tangent ratio and this had been a sine ratio, they both would have been positive. If we go to our third one here, cosine of 30, well, 30 is in quadrant 1, and in quadrant 1, everything's positive. So I don't even have to pay too much attention to the fact that it's cosine. If it's in quadrant 1, it's going to get you a positive result. Sine 310, so 310, that's quadrant 4, and in quadrant 4, cosine is the thing that's positive, so this is negative. Tangent 200, 200 is in quadrant 3, and in quadrant 3, tangent is the positive thing, so this one is actually positive. Right, so when you're in the quadrant that matches that letter, you get a positive result. And then cosine of negative 80, well, that one's a little bit trickier. So negative, remember, we're going backwards. So if you go negative 80, you're going to end up somewhere around here. So that's quadrant 4, and we see cosine is positive in that quadrant. We're working with cosine, so this one also ends up being positive. So we're going to use this ASTC thing for a lot of different things. Let's try putting it to work on a couple of simpler questions now, and then we'll work with it a little bit more later. So if cosine of theta is negative 2/3, I want to know which quadrant or quadrants could I be in. So this is something you're going to have to consider for a lot of different questions in this unit. Usually it's not just going to be a simple question of which quadrant are you in, but you're going to have to think about it as you give answers to other questions. So in this case, cosine theta is negative 2/3. The 2/3 I actually don't care about at all. The only thing that's relevant to me here is just the fact that it's negative. So where is cosine negative? That is the important question. So if we go back to our ASTC, so let's just sketch it over here just to have it something to look at. So cosine is positive in quadrant 4 and in quadrant 1, because everything's positive in quadrant 1, and 4 is the relevant one for cosine. So if we want cosine to be negative, then we need to be in the other two quadrants. So that's quadrant 2 or quadrant 3. And so that's it for this question. So sometimes you're just going to have one piece of info to go off of. Sometimes you might have more than one. So I might give you something different, like say this. So sine theta is less than 0, or sorry, greater than 0, and tangent theta is less than 0. Now I want to know which quadrant or quadrants might I be in. So see if you can answer this one yourself. So use the information you've been given, think about ASTC, decide where your angle should probably be, and then come back and see if you got it right. So if we're thinking ASTC, so sine theta greater than 0. So what does greater than 0 mean? Well, that just means it's positive. So sine is positive in quadrants 1 and 2. So we know we've got to be in at least one of those two things, but we don't just stop there, right? So you don't give two separate answers to this question, one for each set of information. It's an and. So both of these things have to be true. We also need tangent to be less than 0, which means tangent needs to be negative. So that's these two quadrants, right? Because tangent is positive in quadrants 3 and 1, and it's negative in the other two quadrants. So from that, what we've got is if sine is positive and tangent is negative, the only quadrant that fits both of those things is quadrant 2. It's the only one that fell into kind of both of those little highlighting circles that I made there. So that's the only place where sine is positive and tangent is negative. All right, one last question. So I'm going to tell you that tangent of theta is 3/7. And I'm also going to tell you that theta is in quadrant 3. Right, so both useful pieces of information. I want to know some exact values for sine and cosine. So you're going to kind of have to draw together everything that I covered in this video. So see if you can make this one work on your own. I would recommend starting by drawing. So that's always a good place to start. See if you can make something happen with this 3/7. And then work backwards from there and see if you can figure out what your other two ratios are. So if you're totally lost, feel free to just keep watching, but try to pause here and do it on your own. Okay, so to start this off, again, we're going to want just a quick sketch just so that we can kind of visualize what's going on here. So you're told explicitly in the question that your angle is in quadrant 3. So we know we've got something over here. Doesn't really matter where. Not focused on drawing a nice drawing. I'm just going to do something like this. If we didn't have this piece of information, this bit about theta being in quadrant 3, we actually would have had to have considered two possible answers, where theta could have also been in quadrant 1, and so we would have had to do a whole bunch of extra work there. But thankfully, we were narrowed it down to just this place. So now we want to draw our triangle. Remember, going to the x-axis, never the y-axis. And so theta is going to be, well, it's not going to be this angle here technically. Theta should be this whole thing. But remember that whole spiel about reference angles and their angles being the same. So we're really actually just going to work with our reference angle here, so theta r. So from the perspective of theta r, our opposite and our adjacent are given to us by this fact, right? So if tangent theta is 3/7, well, that's just your opposite and your adjacent. Or if you want to think about it the other way, your y and your x. So from that angle, our opposite is 3, our adjacent is 7. Now we need to do r. So r is the square root of x squared plus y squared. So that's going to be the square root of 7 squared plus 3 squared. So we've got 49 plus 9, which is the square root of 58. So that's going to go on our hypotenuse here. It's root 58. Just realized I forgot to draw my angle on my arrow on my angle. So don't forget that. So now our sine ratio, well, we can just get that with SOHCAHTOA. So from the perspective of this angle over here, theta r, our opposite is 3, and our hypotenuse is root 58, and so we get 3 over root 58. Our cosine ratio, same idea, our adjacent is 7, and our hypotenuse is still root 58, and so we get this. You could have also gotten that, again, from the y over r and x over r stuff. Same idea. The only problem here is that this is wrong. So if we think about ASTC stuff, we're in quadrant 3. And in quadrant 3, so down here, sine and cosine should both be negative. But we ended up with positive answers for both of these ratios. So what gives? So it's pretty simple. If you're thinking about the fact that we're in quadrant 3, your x and y values should both be negative, right? So when we drew this triangle over here, this should have actually been -7 and -3. It's just that when we had our tangent ratio here, those negatives had already been canceled out for us before it was given. So if we make that a -3 and a -7, it won't really affect our Pythagorean theorem at all because they would have just gotten canceled out anyways. But that does mean that our ratios at the end here are now -3 over root 58 and -7 over root 58, which gets us the negatives as we should have had. And so there you go. That does it for your trig ratios on the coordinate plane. So for the next video, you should be now hopping back into section 2.1. So you're going to do 2.1.3, which is about something called special triangles. And then you're actually going to come back to 2.2 after that. So once you're ready, go take a look at that, and then you can come back to 2.2 in a bit.